Now suppose you have the integral of 1 plus square root of x, and this guy is raised to power 9, and you divide it by square root of x. And you're going to take the integral with respect to x. So let us apply the method of substitution. U is equal to the quantity inside parentheses raised to power 9. We're going to skip the power 9. You're just going to take this quantity in red, which is 1 plus square root of x. But what is du? Du is the derivative of 1 is equal to 0. The derivative of square root of x is 1 divided by 2 square root of x dx. Remember that square root of x is x to power a half. When you're taking the derivative, it becomes a half x to power negative a half, or 1 divided by 2 square root of x. This is what you learn in elementary calculus. So let us continue. Our integral is now the integral of, you have u to power 9, you have square root of x down here, and dx can be written as 2 times square root of x du. So wherever you see dx, you're going to write down 2 square root of x du. And it helps us to get rid of square root of x. We have square root of x on the denominator, square root of x on the numerator. So the integral is u to power 9 times 2, and then du, which is super easy for us to calculate. Whenever you have the integral of u to power n du, this is u to power n plus 1 divided by n plus 1 plus constant of integration. So we're going to use this. The integral of u to power 9 du is equal to u to power 10 divided by 10 plus c. So this integral is 2 divided by 10 u to power 10 plus c, or u to power 10 divided by 5 plus c. Are we done yet? No, not yet. Our u is 1 plus square root of x. So wherever we see u, we're going to substitute that by the quantity in x. You get 1 plus square root of x, everything inside parentheses to power 10 over 5 plus constant of integration. Another interesting example is the integral of cosine of square root of x divided by square root of x dx. So on top, you have a composition of cosine and a function. In these cases, we take the inner function as u. So let u to be square root of x. So du, let me use a different color. Du is equal to 1 over 2 times square root of x dx. Perfect. So dx can be written as 2 times square root of x du. So our integral becomes the integral of cosine of u divided by square root of x, and wherever we see dx, we're going to write down 2 square root of x du. It helps us to eliminate square root of x. So your integral became a simple integral of 2 cosine of u du that you already know how to calculate. This is a familiar integral. We know that the integral of cosine of u du is sine u plus c. It has a 2 in front of it. So you get 2 times sine u plus constant of integration and substitute u back to get a function in x. This guy is equal to 2 times sine of square root of x plus constant of integration.